Hey, okay. Welcome everyone to my channel. This is Maths Made Easy with Terry in 10 minutes. What I'm going to do today, we're going to go to the next form of integral forms. We've done the one for linear function, the previous video. So if you have question about that, just go to the previous video and that will answer that. Now, we're going to talk about there are two types of integrals. Now, there are two types. The first one is where you differentiate the denominator and it's going to give you the numerator. And there's the other one is when you differentiate the numerator, it's a product of it. So that means when you have one of them, okay, you differentiate the denominator, you give the numerator, or you differentiate the first variable, the first function is going to give you the second function. All right, don't worry. In this video, I'm going to just focus on the first one, okay? The second video, I'm going to focus on the second one, where it's a product, where if you differentiate one function, it's going to give you the second function as well, okay? So let's take an example, for instance, okay? Let's say I have, I'm going to want to integrate, let's say something 2x, let's say something as 2x plus 3 divided by, let's say x squared plus 3x minus 5. Okay, 2x plus 3 divided by x squared plus 3x minus 5. Now, if you look at this, when you differentiate this, okay, if you differentiate this, if you've not don't know how to differentiate, I have a video on differentiation, the basic differentiation. Then when you're done with that, you can look at further differentiation. I have a playlist. I will upload all of them so you can have a look. But when you differentiate x squared plus 3x plus minus 5, it's going to give you 2x plus 3, because if you differentiate x squared, it's going to give you 2x. You differentiate 3x, it's going to give you 3. Minus 5 is going to give you 0. So that means this is what we call the integral of f prime divided by f of x. So it has a general formula, all right? But I want us to solve it, assuming we don't know how the formula is being derived, okay? So I'm going to use something similar to the linear function with the substitution method here. You don't need to cram this method of this solution I'm doing now. I want to just get to the final formula. All right. So let me say let z, okay, z to be equal to x squared. I don't know if you can see it from there. So let me put it down here. Okay. So you can see. So I will say let's z to be equal to x squared plus 3x minus 5, okay? So we differentiate dx over dz over dx is going to give us 2x plus 3, okay? But I want to make the x subject of the z subject of the formula. So that means the z is going to be equal to 2x plus 3 dx. So if you look at this now, okay, I can rewrite this now as 2x plus 3 dx. Can you see? 2x plus 3 dx is all the same thing as this. Can you see? So that means the same thing as dz. So I can write dz for that. Divided by x squared plus 3x minus 5 is z. Can you see? So that means I want to integrate the z all over z. And that is the same thing as integrating 1 over z dot du. Sorry, dz. Now, when you integrate 1 over z, that will give you what? Ln z. And that will give you plus c. Can you see? And we know our z to be what? X squared plus 3x minus 5. So it's going to be ln x squared plus 3x minus 5 plus c. Now, if you look at this, you see, what we have done differentiating this, the answer is similar to the question. So that means if you have a particular question in which the denominator differentiates to give you the numerator, what you just need to do is you just put the ln of the denominator plus c. So that means I can now say, when we are integrating f f prime f over f of x, the answer is going to give us the ln of the absolute value of f of x plus c. Okay, so the ln of the positive absolute value, I'll have a video on absolute values, okay, so you can go back and check that, but the ln of f of x plus c. All right, so let's solve some questions now. Let's say I have, number one, I have 3x squared divided by x cubed minus 4. The same thing. If I differentiate this, 3x squared, x cubed minus 4 is going to give me 3x squared. So my answer, when I integrate this, is going to be ln x cubed minus 4 plus c. That's it. We're done. That's it. So in this, in the previous slide here, I was trying to show you how to arrive at the formula, but it is one of the standard derivatives, okay? So if it's the standard derivative form. So if you differentiate the denominator and to give you the numerator, it's going to be the ln of that. So let's pick another example. Sorry, this is number 2. Let's pick another one, number 3. Let's say we are integrating 2x plus 4 divided by x squared plus 4x minus 1. Same thing. Can you see? When I differentiate this, it's going to give me 2x. Differentiate this is going to give me 4 and 0. So that means if I differentiate this, it's going to give me this. So it's still in the same form of f of x, f prime x over f of x. So that means the answer is going to be ln of the denominator, ln x squared plus 4x minus 1 plus c. Easy. All right, so this is one of the simplest integral forms. Let's pick another one. Let's make it trigonometry now, okay? Let's say we have sec squared x divided by what? Tan x. And what would this give you? Sec squared x divided by tan x. Now, when you integrate tan x, it's going to give you sec squared x. So the answer is going to be ln tan x plus what? C. Is this making sense? So if you check, the denominator is the same thing as the numerator. When you differentiate it, the answer is going to be the ln of the what? Denominator. Okay. Let's see number 5. Okay. Let's pick the last one. We're integrating, let's say cot x dx. And we know that cot is the same thing as what? Cosine over sine. Can you see? Okay. Cos over sine. I remember I told you that we have sine, cos, minus sine, minus cos. When you integrate, when you differentiate sine, it's going to give you what? Cos. So that means the answer for this is going to be what? Equal to the ln of sine x plus c. And that is that for that. Easy. All right. So that's what we're talking about. So now this is in this video, we've talked about when you have f prime of x, so such that when you differentiate the denominator, it's going to give us the numerator, okay? All right. But we have some special cases, okay? It's a kind of special examples, all right? We have some special examples. And in these special examples here, it does not directly give us that, okay? So we have some special cases, all right? So it looks similar, but it is not exactly the same thing. So for instance, if I ask you to integrate 6x squared all over x cubed minus 4. Now, when you differentiate the denominator, it's going to give us 3x squared, but not 6x squared, okay? How will you go about this? All right, so now these special cases now is what I'm going to talk about in the next video, all right? So special cases of integration, all right? So how do you go about this? So please don't forget, I'll see you in the next video so that we'll talk about this kind of cases and similar. It's very simple, all right? It's just that in addition to what we've done, you need to add a little more step, just one step, just a little trick to it, and you get the same thing, all right? So I'm going to see you in the next video. So don't forget to like, share, comment, and subscribe. So you know you get notification when I upload new videos, okay? All right, I'm going to see you soon. I'll see you in the next video.